is going to be the algebra after it. Taking the quotient rule is not so terrible. Simplifying it to get it to be what they're going to probably have it look like is more difficult. So, turn my pen on here. Oh, I accidentally went to example 2. There we go. There's example 1. Let you copy that down. This is also a good one for us not to have printed notes on because take a little bit of room and sometimes it's hard to fit it in the box. Hopefully I can fit mine in the box up here. So when we see something like this, we've got 3x minus 4 on top, we got x squared plus 2x on the bottom. We've got x's in both locations. So we're going to have to use a quotient rule for this to be able to take this derivative. We can't use like the love connection. We'll see one later where you could use love connection and then you wouldn't have to do quotient rule. But this one's going to require the quotient rule. So whenever I take the derivative, it asks me to find dy over dx, which is just the derivative. I'm going to use that notation instead of y prime since that's the notation that they use. And I'm going to color code this here for us. So I'm going to do low in blue. I'm going to do high in green. So our rule here, it's not letting me pick my, there. Alright, so my rule is going to be low, put it in parentheses, x squared plus 2x. Everything needs to be in parentheses here. If you don't, you might mess up. Times the derivative of the high. So derivative of 3x minus 4 is just 3. And then you'll have minus. And now we need high. So parentheses. Parentheses are so important here because if you don't have them, you're not going to distribute things correctly. So we got 3x minus 4. And then we got d low, derivative of the low. And so we got x squared plus 2x, so the derivative of that would be 2x plus 2 all over our low squared. So x squared plus 2x squared. Now that's the derivative, that's the calculus. We've done the calculus here. But, again, probably unlikely that you get to leave your answer like that. It is either going to be, they're going to maybe be asking you to plug something in and it'll help to be simplified, or it's multiple choice, in which case they're not leaving the answer like this. So, whenever we simplify this, you just want to, expand on top really here in the beginning. So, I would distribute that 3, and so I'll get 3x squared plus 6x. I've got to multiply this stuff together. Keep a set of parentheses here, because that minus has to get distributed to everything. And, I mean, depending on the capacity you have for doing things in your head, like you could go ahead and multiply this together and then distribute the negative and do it all in one step, but my head has a little bit hard time keeping everything straight there and I forget things. So I'm going to keep my parentheses. I'm going to distribute here. I will get 6x squared. I am going to do this in my head. That's going to give me a 6x. This part's going to give me a negative 8x. When I put that together, I get a minus 2x right there in the middle. So I'm going to go ahead and combine those so I don't have to make another step here. And then I got a minus 8. And then you can distribute that negative. And it's okay if I drop the parentheses here on this first part as well. There. And you can combine your like terms. So you got 3x squared and negative 6x squared is going to give you negative 3x squared. I got a positive 6x, positive 2x. That gives me a positive 8x and a plus 8 on the end. And then x squared plus 2x squared. I don't think that's going to factor. I don't think so. Because it'd have to be a 3x and an x. And then you could do 8 and 1. 8 and 1 won't work. You could do 2 and 4. 2 and 4. Yeah, 2 and 4 won't work. Yeah, one of them would need to be negative. Yeah, I don't believe that will factor. So now they may do this right here. We got negative 3x squared plus 8x plus 8. They might do this. X squared plus 2x has a greatest common factor, right? An x could be pulled out of it. They might do this. They might factor that out, but if they do, it's still inside of the square. So both of those things would have to be squared. So that would be x squared times x plus 2 squared. They may or may not do that. And definitely on a free response, you don't have to do that. I wouldn't do anything like that there, but that's just an option. I think they do that on one of the problems in the book there. Yes? Make this one right here squared. Uh-huh.
Could you take away the x, like the squared on the x on the outside?
Like I've got on this one here.
Oh yeah.
Yeah, you can have it like this. Yes. That would be okay. Or they may not mess with it at all. It may just look like x squared plus 2x squared. It just depends on how they felt that day when they woke up that morning, on how far they wanted to go with that simplifying. Sometimes this factors and then can cancel with something. It does not in this case. So there's not like a obvious reason that you would want to do that. I don't think you'll see the denominator expanded out. They could do it, but I don't think you'll see it, because usually what happens is we want to keep denominators factored so we can see if they cancel with anything in the top, which it doesn't here. Technically, it could be multiplied back, but they do not usually do that. Yes, if it was free response, you could leave it with blue and green. And if it's all they needed, that would be fine. A lot of times they will ask you to, like, talk about horizontal tangents or vertical tangents, and where you do kind of have to simplify to answer the next question that they're asking. And they show up on multiple choice a lot. But if all it asks for, you could stop where it's blue and green. You're looking for where the numerator would be 0. And a vertical tangent was when the denominator would be 0, which we haven't really seen yet, but we'll see some show up like that. All right, let's try another one. Copy this one down. And there's so many things I can think about doing here. First, because I've got a complex fraction, and I don't like complex fractions. I don't want, like, if I just take the derivative like it is right now, I have to do a quotient rule inside of a quotient rule because I've got 1 over x, which would require the quotient rule. And I really don't want to do a quotient rule inside of a quotient rule. That you could get the right answer doing that, but it would be terrible. So you have a few options for how to deal with this here, as far as I want to make it where it's not a complex fraction before I try to do the quotient rule for this. So we could either try to like get rid of the complex fraction altogether, or we could change 1 over x and make it x to the negative 1 power. However, if I do x to the negative 1 power, then I do have negative exponents to deal with throughout there, which I also don't love. So I think what I would do for this is I would try to get rid of the complex fraction before I take the derivative. And you have a couple options. One option that we have been doing is like getting common denominators and flipping and multiplying, which works. But in this one in particular, I am seeing an easier way to do it. Okay? And so I want to show you this strategy that can get rid of complex fractions. It's particularly helpful when your denominator is pretty simple, right? So like all I've got's an x right here. So I could like get common denominators and multiply by an x, but let's try this right here. Use a different color. And so we're not taking the derivative yet. We are, switch to red. Why is it doing that? Oh well. All right, so is it legal for me to multiply the top of this fraction by x and the bottom of this fraction by x? It is, right? So here's why I've chosen to do that. When I do that, I would have to distribute that x. So that would give me 3x on top. And then what do I get when I multiply x times 1 over x? I just get 1. The x's cancel, right? And I'm just left with the 1. So I've got 3x minus 1. It got rid of that fraction. And then on the bottom, I've got x squared plus 5x. So particularly when you have a simple denominator, like there's only one denominator you're needing to get rid of, this is a really good strategy that will work to cancel out that denominator. And now we don't have a complex fraction that we've got to deal with. And now it looks a lot like the question that we just did, right? So if I'm wanting to take the derivative of this, I'm going to use blue for the bottom. I'm going to use green for the top there. So f prime of x is going to equal low, in parentheses, x squared plus 5x times d high, the derivative of the high, which is just 3 right here, and then high, which is 3x minus 1, times the derivative of the low, x squared. Oh, wait. Gosh, I can't erase it. What did I forget to do there? I was just writing x squared plus 5x, which is wrong. Got to take the derivative. 2x plus 5 here over low squared like that. Very similar to the last problem now, right? I'm going to freeze my screen while I simplify this. I want you guys to try to simplify it on your own. They can get worse. Yeah. When we learn chain rule so beginning of Unit 3, it won't happen this unit. Beginning of Unit 3, we're going to learn chain rule, and then they get way worse. So prepare yourself. No. Well, if you get trig or something in there, they sometimes won't simplify as much. So possibly, because they're yeah. So yeah. So here's what I have here. Double check me. Does it look like what you guys have? I did choose to factor out that x in the bottom and write it separate. You don't necessarily have to. Are you guys getting the same thing in your numerator here? Okay. Now, this one will factor. You could factor out a negative, which would make this 3x squared minus 2x minus 5. And then you could do 3x minus 5 and x plus 1, because negative 5 and 1 will multiply to give you negative 5. Here you would get negative 5x. Here you would get positive 3x. That would give you negative 2. So it is possible that they might do this, 3x minus 5, x plus 1 over x squared times x plus 5 squared. It will factor. I just find it a lot easier to factor if your squared term is positive, because like your rules of factoring work better if you do that. But you could have the negative on the inside and it would factor there as well. So they might do this. Nothing cancels once you factor, so there's not a major advantage to doing that, but they could possibly factor it for that. Again, without having it like presented to us in a multiple choice sort of format, there's no secret way that you have to leave the answer. What I want you doing on the assignment is I want you like looking at the answer in the back of the book and making sure you can get your answer to match theirs. And if you can do that, then you should be in pretty good shape. Okay, questions? All right. Okay. Try this one on your own. I could have love connectioned this right here because I've only got one thing on the bottom. And if you do that, you're getting x to the third over x squared, which is just x. And you're doing 4x over x squared, which cancels one of those, and I could write that as 4x to the negative 1. And then I could use the power rule. Derivative of x is just 1. Here, multiply. Positive 4x, x to the negative 2. Send this back down to the bottom. And if I want, I find it interesting, Molly had x squared plus 4 over x squared as her answer, but then she, divided each one. She did use the, love connection there, and she has the 1 plus 4x squared as her final answer. But if you wanted to, you could get common denominators, just multiply by x squared on top and bottom, and then you would get straight to the answer that most of you were getting with the quotient rule, right? So you can definitely use quotient rule on this. But because there's only one thing on the bottom, you could use love connection first. Just divide both of those there. Or sometimes some of you will do it this way, like do x to the negative 2 times x to the third minus 4x and distribute. That's the way some of you think of it instead of like a love connection. And that will be quicker. But I kind of wanted you to try it with quotient rule to see. Can somebody let me borrow theirs that did? I think everybody was doing quotient rule. Understandably so, because I didn't even give you a hint that you could do anything else. Let's see who I've got here. Let's look at Molly's here. Real quick. Just to see it done the other way. Alright, why didn't it? Oh, here it comes. Why is it? There it is. Okay. This whiteboard this. That's blurry. Okay. I'll hand this back to you, Molly.
Is there any other way to do it? Just on the regular problem, just quotient rule. Is there another way to do it?
Once we use chain rule, yes. Once we learn chain rule, yes, we could avoid it, but for now, no. Like on this problem, you could do love connection, but most of them are not going to be like that. So when we learn the chain rule, you can turn everything into a product rule with a chain rule involved. Sometimes I think quotient rule is still just easier, but there is a way around it once we learn that, but we don't learn that until 3.1. So you'll definitely have to know quotient rule for this test. There. So you can, I think most everybody had this first step. They're the same. You can multiply these together, and Molly went ahead and distributed her negative right there. And then a lot of you were getting x to the fourth plus 4x squared over x to the fourth. But that will factor and simplify. So you could pull out an x squared out of the top of that. And so you'd have x squared plus 4 times x squared. And then in the bottom, you can cancel this x squared with 2 of the x squareds down here, or 2 of the x's down here, leaving you with x squared plus 4 over x squared. And then Molly even did use the love connection here. She used it at the end, love connectioned her answer, and got the step I had before this here, which might be how they leave the answer. Who knows? We'll just have to check the back of the book and see for those. So it still works. It's not necessarily the most efficient way to do the problem, but it still works just fine if you do the quotient rule for that. Okay, questions? All right, how many more do I have? Just one more. Let's do one with some trig. Yep.
Is there a different rule for this, or is it the same trig?
Same rule. It just has trig in it. bad thing about trig is that it's trig and it makes us all panic. The good thing about trig is that a lot of times you're not going to be able to simplify as much whenever you have trig. So it kind of is like what you get as your answer is your answer. Lucas needs this one. Hello? That's okay. I do. Yes. Okay. Thanks. Bye. Molly, they need you up at the office. Okay. All right. So here's our question. Now, I wrote it differently just because I want to expose you to several different ways that they may ask you to find a derivative. So they give you the function, and then instead of saying find f prime, they say write an expression that gives the slope of the line tangent to f of x for any x value. The slope of the line tangent to f of x is f prime of x, right? So they're just asking for the derivative here. So copy it down if you want, or don't, it's fine. For that. So, you know, we are in the same situation here. We've got low and high here. So, to do this problem, we will have f prime of x equals low, which is sine x. And these parentheses may or may not be all that critical that we have them, but I would put them every time, even on a problem like this, because if you don't do them right, you'll forget to distribute when you should distribute. So we got low times the derivative of the high. What's the derivative of 1? 0. It goes away, right? So I really just have the derivative of negative cosine x. What is the derivative of negative cosine x going to be? The derivative of cosine is negative sine x. If I throw that extra negative in front of it, it's going to be a positive sine x. Minus high 1 minus cosine x times the derivative of the bottom, derivative of low. Derivative of sine is cosine of x all over low squared. Mm-hmm.
Off this, you can cancel the two sides from the bottom side, right?
No,
You can't.
you cannot,
Because the minus is
because of that minus sign. In fact, Lucas tried to do this over here on the last problem. He had x to the fourth, x to the fourth. He just marked them out. It killed a math fairy somewhere. And just your suggestion that we do something like that killed another one. We're killing them left and right today. So between you and Lucas, we're down at least 2 math fairies. You didn't actually do it. It was a threat for murder, I think. So I am going to write this as sine squared x, because sine x times sine x is sine squared x. And then I'm going to distribute this cosine right here. I'm going to keep that minus. It's going to be cosine x minus cosine squared x. And I'm going to write that denominator, I'm going to write it with this notation, sine squared x. It means the same thing as sine x squared, but it's just more common for us to see it this way. And Connor's suggestion that we mark out this sine squared with this sine squared is ludicrous. We should not do that because there's a minus sign right here, so we can't do that. If we didn't have the minus sign, if it was multiplied, then we would be able to, but we can't. So I'm going to distribute that negative. Okay. And anything we can combine, they're probably not going to leave the answer like this. There's a trig identity lurking in here somewhere. Sine squared plus cosine squared equals 1. And I've got here a sine squared and a positive cosine squared, right? Those two right there. So I'm going to write this step. You don't have to. Like if I've got sine squared x plus cosine squared x minus cosine x over sine squared x. You don't necessarily have to write that step, but then this sine squared x plus cosine squared x could be replaced with 1. Since it's like addition and subtraction, yes, you can just change that order there. Now you need to keep signs with it, so like that cosine x has to keep the negative that goes with it there. But we can reorder those things. And they'll probably stop here, I think. There's other, like you could multiply by 1 minus cosine x on top and bottom and then change some of that stuff. But it would just like sort of flip-flop what you're looking at. I don't think they would do that. I think they'd stop here. These are fairly straightforward unless they start throwing some weird identities in the simplifying part of it. So, here is your assignment. There's a warning here. Most of these will require the quotient rule, but not all. So there's a few of them that you can do some, there's a few of them that you can do some like love connection stuff first, and then you don't have to use the quotient rule.
If you do quotient rule for all of them, they still work.
Should work, yes. Should still work. Also, tomorrow is going to be sort of a practice day. Okay, so tomorrow we will go over one of the FRQ questions. I have a worksheet that has some product rule and quotient rule on it that we're going to do. And then we also will have this. I'm not going to make this due until Friday. There. So it is going to be due on Friday. We do have some other things that we're going to be doing in class tomorrow. So I would not wait till tomorrow to do all of it unless you're just not very busy tomorrow. But when we got like 12 minutes, you can get started here. I also am going to give you 2 skips on this assignment. So if there's one you are stuck on or it just looks too awful and you don't want to try it at all, I give you 2 skips on these. I do not offer skips on tests. You're welcome to skip them, but you will lose points. So you got about 10 minutes, so go ahead and try to get